Hi, today I'm going to try plotting publicly available data from World Bank and using MATLAB or Octave side by side with R, and then trying to use parametric fitting to understand or predict what the data pattern is like using polynomial regression and general linear regression. Okay, first we'd like to find the data. Now I'm getting the data from World Bank, and there's data that I've been playing with, and I tried to visualize the school enrollment data. So this is how the plot is like for Indonesia, and then there's a data bank for all of the countries. Now you can download the data here. Okay, and I'd like to download this CSV. Okay, now I actually already downloaded it, but I'll make it again just to make it better, and so you know how to prepare this data. Now this data, if we try to just load it into Octave or MATLAB, okay, I'll show you how it looks like. This is a comma separated data, so this is how it looks like. Now if you try to load it just into MATLAB or Octave, it won't be so nice. So this is how it looks like. Now, okay, I have to let's put it into n row. Now you can see that. Now let's see the first. So you can see the local variables. It's not really necessary, I guess. I'll try to increase the font size, so I hope you can see that a little clearer. Okay, 12. Okay, I have to reload it, no problem. And I'm gonna zoom this out too. Okay, I guess 150% would be good. Okay, this is the data, and indicator name and data for each one. Now if you try to load this data, again, and try to get the first row, you can see there's nothing here in the first row because it's just text here, and the second row is definitely nothing there. And even if you try to get the third row, there's 0 there, because even if this is numeric, and I'm gonna try the fourth row, there should be something here, but it's still all zeros. This is because if you look at it in the text file, each of the data is double quoted, and MATLAB doesn't like that, or Octave doesn't like that. So what I'm gonna do is I will resave this data. No. I will resave it, and I will also remove the title here, so that the first row is just the headers. So I can save it here and use the text CSV format, and then you can look at after saving. Now these numbers become just numbers, not quoted. And if I reload the file again, I'm trying to see the first column, the first row, and the header years here, and I also have the second row, which is the first data, and we have correctly loaded the data. But I guess that won't be so interesting, because having the header rows are not necessary. So we'll just reload it again and put the first row that we want to read the file. This is the second row. Oops, sorry. The second row means the index 1, because it's a 0 base. So this is a row 0, and then I'm just gonna get the first column of data, which is column E. That means it's the fifth column, so I'm gonna put 4 here. Okay, now end row 1 just contains the real data from year 1960 to year 2014, although notably there are no data for 2014 at all, just and very few data for 2013. So now that we have this, I can freeze it so we can look at that for reference in Excel or in LibreOffice Calc. Now, after doing this, we can do such things like calculate the mean for Aruba country. So the mean is 27, but of course this is, includes the zeros here, and that's not very accurate. So let's just calculate the mean for year, let's say, I think if Aruba is there, that means that 55 through 57. That's right. A through E. 0, 1, 2, 3. Oops. 0, 1, 2, 3, 4. Yeah, that's true. And okay, so I guess I'll just gonna sum the second to last data. So that will be this, which is column 53. So you can find the mean of column 33. Okay. Yep. Okay, so the mean is 74. There are missing values also, but they are read as 0. And if I want to calculate the mean of Aruba itself, just gonna get the mean of Aruba, which is 27. So and then let's try how to do this in RStudio. R is more forgiving for this, so you can just load this file using read.csv, and you can see that R has a support for a header. You can just say header true. So I'm gonna paste the file again, and notice that I'm using the file scheme here, and R is capable of reading that. Okay, I have to put this on n row. Okay. And now this is n row, and now we can also see the values for the first column. These are the names, and the nice thing about R is that it's the CSV reader supports text or character data, and you are not limited to matrices. Now, since this is also a you can look up the names of the columns and rows by using dim names. So this is the row dimension. It's just the row numbers, and this is the column names. So we can refer to a data just by using the column name instead of the column number. So we can also get this. Okay. Now R also has a nice shortcut for doing this. Is just use the $ sign to get it. And the nice thing about this is that now we can perform calculations based on the column name rather than the index of the column. So I'm gonna try getting into what was that year that we are finding here, column 33. I think that's 2012. So I'm gonna get 2012 head of K. And also the nice thing is that it automatically translates the missing values into NA. And let's try what happens if I do mean. It gives a not available. So, and that's true because you cannot do mean to calculate the mean if there are missing values. So what we need to do is that we use NA dot omit from n row for 2012. Now we can get the mean, and this is a accurate mean, and we can also get the mean for the country of Aruba. Okay, let me try and get it. Okay. Okay, this is the data for Aruba, and should get the data just for and get the range of columns. How do I get? Okay, just range. Okay, so that will be the range from column 5 to column. How many columns are there? 59. Okay, let's omit the head. Or can I just use the MATLAB syntax? Okay. Now this is the data just for Aruba, and we can calculate the mean of this. Of course, it's not logical, not numeric, so we can omit this. And okay, it's still error. I wonder why it still returns an error. Oh, okay. Sorry. That should be. I think I should convert this to a vector first. Okay. Or maybe I'll try converting this n row to a data frame. Okay, and let me see if this gives me the still the same. Still the same. Okay, row as vector. Okay. Okay, now we have to do as vector. Okay, let's try this again. As vector. And let's try just this. Okay, let's try as numeric. Okay, that's what we are looking for. And okay, after this, then we can do NA omit, and now we can do the NA for this. Wait, what is that? Why is there's ATTR, NA action, and NA class? Is S vector here is any effect? Nothing. So just S numeric is required. So, and then we get the mean of this row for Aruba. Okay, now we want to do some plotting. First, I'm going to plot this plot for Aruba, but maybe I want to switch the plot. Oh no, the plot for a year 2012. Okay. And gonna do a histogram of that. And this is the histogram, so most of the values are around 110%, and but there are some of those in the 0, so I want to omit that. How do I do subselect in MATLAB from a vector? Okay. So all I have to do is just to make this X to 2012 and where this is greater than 0. Okay, now I'm gonna make this into X 2012 and then I'll plot the histogram of that. Okay, so this is a real histogram without missing values included, and I'm gonna try doing the same histogram using R. So the X 2012 is similar to the above. It's numeric and row 1 No. This is the year 2012. So, do I have to do S numeric? I don't think so. So that's X 2012. And I'm gonna do a histogram of that. And this is the plot. Okay. So curiously, it's not the same thing. I think it's because we have different number of pins. Let's try making it 10. So it should be the same number of pins. Let's try making it. And let's confirm that they are actually the same data. No, it's not the same data. But how come it's not the same data? Okay, let me check again from the Excel, the CSV, 8. Okay. This is the end row. From here to 33, 0028. Where is this? Okay, so I guess I was mistaken. Sorry. Okay. What's column 33? Oh, column 33 on that year. Okay, 2012 should be column 53. Okay, that should be column 54. Yeah, 2012 should be column 54. Let's redo that again and make it so that we just do where it's greater than 0 and then make a histogram of it. There. Okay, now it's the same histogram. No, it's still not the same histogram. Okay, using the same number of pins. Still not the same histogram. That's weird. It's definitely the same data. Okay, so I'm not sure why the histogram is different, but let's just continue. So after doing the histogram, what I'd like to do is plot countries' development over the years. So I will pick Indonesia here. Let me see, Indonesia is in what column? What row? And row. Country name. So Indonesia is in row 98. So the data is I'll omit and make it numeric for n row 98, column 5 through the last one. How do we get the, okay, 5 to 59. 59. Okay, now that's Indonesia's values. And I'm also going to get the same from MATLAB or Octave. And let's try. This should be the same. 98. And which column would this be? I think it's all columns then. Okay. So it is the same data. Oh, yeah, it should be the same data, but I need to omit this. And it's bigger than 0. Okay. Now we have the same data. After that, then I'm gonna plot this using a scatter plot from okay, actually I cannot omit the data because then it will be different than the actual data, so I'm just gonna return it back to the original. And then I'm gonna make another vector for years. This is from year 1960 to 2012, and plot this using a scatter plot. The X is years, and then it's the Indonesian data, and then I want it to be filled, so you can look at it easier. Government arguments. Okay, so it's different. Okay, so this should be 2014, I guess. Why do we have two excessive data? That's weird. Indonesia 8. So this is 2012. It's 2013, 2014, and this 2015. So what's this first column? That's weird. It's column 0, 1, 2, 3, 4. I think I've loaded it correctly. Yeah. Is there any double columns here? This is really weird. But anyway, just for the sake of keeping conformance with the data, just follow the data. Okay, so this should be the scatter plot of the years from 1960 to the years, and then there are 3 zeros here. Okay, now let's do this using R. So R should have a scatter 2. Let's this plot. Put the I have to put the years too here. 1960. What's the length of this? This is for 1. The length of this 57. Okay, that's weird. Okay, that's strange. Oh, I omitted it. So okay, should not do an omit here. $55, and this is 57. I think R and Octave reads the CSV file differently. So as you can see, it reads the CSV file correctly when there are only 2 years, the 2013 and 2014, that is not included here. So there should be only 55 data. But this has 57 data. I think I may have done the loading somewhat incorrectly before. So I'm gonna try this again from the 5th column. This means it will read from the 6th column actually. Let's see, it's very weird. And after doing that, I'm gonna get the int data. Okay, that's more correct. Although I don't really get it, because this column 1, column 2, column 3, 4, and 5. Okay. Oh, sorry. I did the math wrong. This is column 0, 1, 2, 3, 4. This should be a zero-based column. Let me try again. Column offsets. This is the first value. C1 is 0. So, okay, I don't know why the offsets are amiss here. So let's just go with it. And after I'm getting the Indonesian values, I'm getting this one. And I do the scatter plot again. This time I want the years to be correct. Okay, and do the scatter plot again. How many? Oops, I should not filter it. Okay, this is the scatter plot again, and the R. Let's plot this one. Okay, years is from 1960 to 2014. R gets the correct number of years here. The X is years, and then the int here. Okay, now this is the plot. So this is exactly the same plot, just a different scale. Okay, I guess to make the plot more interesting and accurate, I'll change the zeros with another number. And then let's try again. Okay, that's the better scatter plot. So now let's try doing the polyfit function for this data. years, and we put the data there. 6. We'll put 6 polynomial coefficients, and it doesn't work because there are another numbers. So let's see if it's possible to do polyfit with another number. What's interrupt 1? Maybe not this one. In paint nets. Okay. Wow, that's amazing. I think it's this might work, but okay, let's try. Guess nothing wrong with this. Okay. I think this logic is too complicated this time, so I just omit all the nands for this purpose. So back to omitting all of the nands. Okay, and then I'm not going to use years now because now it's not going to be accurate. Just gonna use t data. Okay, and I'm gonna replot this again. So okay, and that's the histogram. Oh, I guess the histogram doesn't really make sense. T data and int and field. Okay, this is the plot, and I'm also going to match that with the RStudio data, and then plot that. Okay, t data is 1 to length of int, and plot that. Okay, that's the same plot. So now I'm gonna do the polyfit function again for t data and Indonesian data and 6 polynomial. Okay, now we have the polyfit. Okay, so we already have this plot right here. So I'm gonna hold on, and I'm going to make the timeline for the polynomial regression from several years before to several years after. So the last year's is year 41, the 41st year. So just gonna predict like 50 years. So, and to make it more smooth, I'm gonna use 0.2 steps. And that's the tfit, and then I'm going to run the function using polyfile using the tfit. and that's the y fit. And then I'm gonna plot t fit, the y fit, paste on t fit, and use red line and with a big line width so you can see it clearer. Okay, so this is the plot, and that's the polynomial regression of this data. And frankly speaking, this does not look realistic. So let's try this again based on a p coefficient of maybe like 10. Who knows? It might be better. And then I'm gonna do the y fit again. And then I'm gonna plot this again. This time I'm gonna use a green line for the 10-degree polynomial. Okay, this is the 10-degree polynomial. I think this one is even worse. So this time let's just try to have a 3rd-degree polynomial. Who knows? It might be somewhat more realistic. And gonna create a new figure. I'm gonna plot that the first scatter. Okay. And then I'm gonna calculate the y fit, and then do the plot again. Okay, green line is fine. Oops, I forgot to put hold on in there. Let me do that again. The scatter and the hold on and the plot. Okay. Actually, this is better than the 6 and 10-degree polynomial. It's well, it's still maybe not too realistic, but at least it looks quite awesome. Okay, now that we can have that. Let's try doing that using R. So how to do polyfit in R? Okay. Okay, that's the fitting by polynomial. I think this is the same thing. So this is an Pragma package. So I'm just going to make sure that we have that package before moving on. Nope. So let's find this package first. Nothing yet, so let's search. We need to install this thing. Okay, then install. Okay. And it's done, and we can use library Pragma here. And then we can use the polyfit function. I'm gonna use tfit just like I did in Octave or MATLAB, from -5, 0.2 step to 50 years. To make the steps. Range and step. Okay. Do a sec. Okay. So this should be tfit sec -5 to 50 by 0.2. Okay. And then we do the plotting of the, and let's calculate the y fit. Is that a polyfile? Yes. Hey, we don't do the p coefficient first. Poly fit, if the t fit, and then data, and then let's use 3 because it's okay. Must be the same length. No, sorry, should be t data. Okay, and let's compare the coefficients generated by R compared to Octave. So it's exactly the same. Now we can calculate the y fit. Is the polyfile of coefficients by t fit, and then we can plot this t fit based on y fit. Then there should be a guillaume here. Let me try to find it. Well, okay, type is L. Okay, and how to do hold on in R? Okay, I guess I'll just use lines. So first I'm gonna plot the int data, and then I'm gonna use lines for the t fit and y fit with color of green. Okay, now we have the exact same plot in both R and MATLAB or Octave. Thank you.